Good morning, everybody. Chris was just singing the Brady Bunch theme about Goliath because we were trying to figure out which way to do this. This is our very intense version. Welcome to Tuesday. It is Hackster Café. And as you know, every Tuesday at 10 a.m. Pacific, we have an interview with really cool people from the hardware community. This week's is two complete sort of rock stars in the hardware community. We've got Chris Gammell and Mike Szczys. I think I said your name wrong, actually. It's Szczys, right?
It's Stish, like S-T-I-S-H.
Stish. Cool.
You can call me Mike.
I try to do it like what I think is like the Polish way, which is like in my brain is like Szczys, but
that's right, actually. Yeah, people that speak Polish who have talked to me have told me that it's like Szczys. I can't do it. It's just Americanized.
I will respect your pronunciation, and we can put this whole thing behind us. But we should talk about it sometime, maybe. Polish. My name is Głowacki, technically. All right, so you're here because Golioth IoT. Well, because you're awesome, but also you're working with Golioth IoT, and I would love to hear about what that is and what you're doing with it.
Mike, go ahead.
Like to take it away? Cool.
Mike and I go back and forth trying to like rewrite the pitch over and over again because
it never ends.
It's tough to do this. So maybe Mike tries, then I try.
So Golioth is a device management cloud. The thing is, as we attach more and more things to the internet, you start to realize that things get very painful when you move past 10 or 20 devices to 100 or 1,000. And you have to do things like, are my devices all healthy and running? I find a bug in my code. How can I push an update to my devices? I have 10,000 devices sending data back. How do I know what data came from what place? And Golioth has tools that are already built in. It's a hardware agnostic platform that lets you do all that stuff over there, updates, data management, and command and control of your connected devices.
Wonderful.
That was really good, Mike. He's getting good.
Oh,
that was very good.
Thank you.
So what kinds of devices would people be doing with this? Obviously, fleet management kind of implies sort of, vehicle fleets. You can have like shipping stuff and even like packages as well. But also like what other types of applications do you see people using this for?
Well, application side is one thing, but then I think like, this is probably a pretty hardware centric crowd, I would imagine. And so I usually talk first about like the kind of the variety of different technology types you can use to connect.
Oh, please do.
Yeah. So we we have like kind of like top tier supported things. So our one thing we'll show you today is the NRF9160. That's the cellular module from Nordic Semiconductor. That's like that's what I go to all the time. I love using it. We also use Espressif ESP32 for Wi-Fi. So now you have cellular Wi-Fi. We also have NXP IMX RT1060, which is the same one that's on the Teensy 4. And so that gives you Ethernet native, super, super easy, super powerful processor. And NRF52840, which is a Bluetooth chip normally, but it also has a 802.15.4 Mac inside of it. So basically it can do thread. And that's the demo that I'm going to show here today. And so basically those four types of connectivity mechanisms, that's probably the thing people care about most. Now, we don't just support those. Those are just kind of our top tier things that we talk about. But anything that runs Zephyr, anything that has CoAP built into it, and then has a way to talk to the internet, that can potentially run Golioth and talk back to our servers. But it doesn't even just have to be Zephyr. Then we also support Espressif using ESP IDF as well.
Cool. Even the microbit. Wow.
Yeah. So the things, the microbit would have to be in thread mode. So you'd basically be like revamping that whole thing.
Cool.
But the main thing to think about is like we usually talk about the real-time operating system. So Zephyr or ESP IDF. And there's some other ones that we are working on now. But the real thing is all of these things are just on the device side. We build code and examples to try and make it easier to talk back to the internet and to the Golioth servers and the endpoints that we create. And then we enable a lot of different functionalities like Mike talked about that make it really easy and kind of like already halfway to done using all of the things that we have on the cloud side of things.
Wonderful. What are your favorite ones to work with? You mentioned the NRF9160 and the ESP32. What do you like about those and why do you keep going back to them?
I really like the NRF 9160 because I love industrial stuff, and relying on someone else's Wi-Fi network just is not the way to live life. And so basically having an always there connection, having a low power device like the NRF 9160 versus like comparing it to like something with a Raspberry Pi or a full Linux computer and a cell modem on top of that. This is actually a battery powered device. You can actually use something that has, a 500 milliamp hour battery. That's what's on my desk, and I'll be showing later. So
nice. Yes, everyone. This is what I'm especially excited about is the fact that we've got some live demos, and you sent me some photos, and they're so gorgeous. And I've been looking at Mike's Twitter as well. We've got, of course, everyone you can follow Golioth on Twitter, and then there's also Chris and Mike. But yeah, Mike's been posting these gorgeous photos of the AgTech demo platform and this blue device cloud thingy. Oh my gosh, I just noticed that you have a matching USB cable. No.
Oh yeah,
no
you gotta get cables that match the color of the demos. That's half the fun.
Oh, I was showing the thing. Everybody look at it. It's so pretty. We gotta zoom in to show the cable. All right, here we go.
So this is called the Aludel platform. This is basically, it's like a really generic, it's a feather header for plugging in feather boards, and really to show the swappability as well, so that you could swap out between an NRF 9160 and an ESP32, or basically anything that's in a feather form factor. And then it's got other things on board like click headers and quick headers and stemma, and all of these different things to basically make it easy to piece together demos. We built this for ourselves first. And then there's a cable that goes up to the faceplate. So Mike's showing it here. So we call it the Aludel base at the bottom there. And that's just got all the headers. It's really pretty simple to plug together. Kind of stuff.
Yeah, so I have a weather sensor click. This is temperature, pressure, humidity that's plugged into a header here, and then this is an Ethernet. It's a WISNet W5500. So Chris talked before about the NXP MIMX RT1060 is Ethernet, but this is a different chipset that also is Ethernet. Just talking to this, this is an Adafruit NRF 52840 feather. And one of the things when I got ready for the show, I was doing some dev work on this board on Friday, and I was like, oh, I want it to work when we do our call with a Hackster Café. And I didn't think about this, but I have another one. So I just popped out the known working board and then popped this one and did the dev work. And then it was not ready. Like it was almost there, but I'm changing over a ton of stuff. And so this morning I just popped it back out again, and it worked great. And I mean, the thought is, like, if you're a dev shop and you're building devices for different customers, you can basically, like the cost of rolling a circuit board for a faceplate like this is pretty low. Like $20, you can probably get a board like this run. All the stuff inside you could switch this out. We have a feather that does the cellular, the NRF 9160. I've run, if you can get them, STM32 feathers on here as well. Whatever your customer needs, you can switch these boards out and like kind of reuse the same code. So I think for proofing out, like, hey, can we get this contract? Can we go to market with this device? Getting something up and running quickly on a modular platform like this is a really good idea.
Oh, this is a very gorgeous demo. So it's you're streaming data from these sensors up to the cloud, and you're visualizing that with the little LEDs?
Yeah, exactly. So
simultaneously going to 3 separate clouds?
Right now it is, yeah. So we have it hooked up. It goes. The chip communicates with the Golioth servers. It's secure by default, so it's encrypted communications. I can actually select from the device just by pressing the button, like which temperature, humidity, and pressure sensors I want to be recorded. And then once they get to Golioth, we have output streams that seamlessly connect them to your cloud of choice. So like, let's say your cloud team wanted to use Azure. It's really easy to set that up, but down the road, you're like, oh, maybe we should have gone with AWS. You can set things up so that your devices are sending data to both platforms so that you can, spec out the new one before you shut the old one off.
That is so cool. We've got lots of positive comments about your demo here. Morgan Allen is here asking about, actually, might as well mention this. Hackaday SuperCon is coming up, and I know that y'all both have some a little bit of background there, just a little bit. And Morgan also says, some of my favorite folks. Are we going to see you all next month in Pasadena? I will be there.
Mike and I will both be there. We're actually giving a workshop for Golioth.
Cool.
Yeah, we're very excited. Actually, we're going to be using the for demos and for training. We use the mag tag, the
I love that thing.
Yeah, these
Never
things
used
are
it, but
amazing. 35
cool.
bucks. It's got an e-paper screen. Mike rewrote a driver to make it work with Zephyr. On the backside, it's ESP32S2. So you can use it with Golioth, either using Zephyr or ESP IDF. We have examples for both. We'll be doing training in Zephyr. Then it's got some sensors, a little buzzer, LEDs, buttons. But like 35 bucks. I mean, nice job, Lamar and Phil. Just quality hardware like usual. And so it's really great for doing trainings and stuff like that.
Absolutely. Oh, that's so exciting. And then we also have another positive feedback about your demo, Mike.
Thank you.
But that's not all. There's another one too, right?
Yeah. Do you want to look at you want to see the green one?
If it's time, we could also go on other stuff and save it for later.
Always blue. All right. So it's fun having the weather sensor, but the real love of my life is the green demo. So if you think of having like a greenhouse, like industrial scale greenhouse, you're going to use natural sunlight as much as possible. But if you have days that are getting shorter at the end of the season, or if there are, let's say forest fires, and so you have a lot of smoke and the light isn't quite as bright, you want to augment the growing with grow lights, but you want to do it as efficiently as possible, so you're not just burning electricity. So we put together this demo. It has this little light intensity sensor right here, and this is our plant that we're growing, and we have a smart lamp right here, which I'm super geeked out about because it is completely wireless and not talking to anything. Nice. So it has an ESP32 inside of it that is running Zephyr and talking to Golioth, and it's listening for this device, which is taking readings from the light intensity sensor. And so if we come along and put some other bright light right next to it, then we'll see the lamp will slowly tune down and go off. And let's see, so there's, Alex, can you throw up the dashboard that I have on my other tab?
Oh, yes.
Yeah, so you can see here right now I'm blasting that light sensor with this extra light right here. And so the intensity level has gone way, way up. When I take it away, the intensity drops back down. And I'm actually targeting a light intensity of like 1200 right here. So it's going to kind of yo-yo back and forth. Right now, the lamp is completely off until it finds its equilibrium. And then along with that, so it is coming back on again. Along with that, it's like once you get the data reporting back to Golioth and you have the devices listening to Golioth, then like any REST API that you want to do can control these things. So I just made a little Node-RED app here that you can like load up on your phone. And so I can change like the light intensity setting. Right now it's looking for 1200 and it's at 448, like growing back again. I could, temporarily turn the lamp off and it'll go off like that. And then you'll see it kind of yo-yo back and forth again. I could reset the intensity so that it was like quite a bit lower so that you use the lamp as little as possible. But I think the point is, if you install these throughout your grow house, you can, even if there's a passing cloud that comes over like half of the greenhouse, you don't have to turn on all the lights at the time. And over a long period of time, you can save a lot of electricity this way. I also think Chris's demo is going to be interesting to talk about because, in this case, I am using, Ethernet for the sensor and I'm using Wi-Fi for the lamp. But probably an even better idea would be to go with something like a thread network, which is a like self-organizing mesh network. And Chris has a red demo that's based on that transport or that connectivity.
Yeah, and in a large situation like a greenhouse, it totally makes sense to do a mesh network where normally with those, they'll sort of extend themselves, like you can sort of leapfrog and hop the signal from one to the other. Perfect for like super large installations.
Right, and we actually hear from people that are working in like industrial lighting applications where like thread is really popular for them because it really doesn't matter where you place the lights. You can the thread network will automatically align itself and find its way back to like the main controller. And so after you do the install, then you can go through and like map out like here, these light switches turn these lights on and off, or they set the brightness and dimness. And so you're not kind of, if you think about traditional wiring in a house, the light switch connects to the light And so if you want your light switch now to also turn on 2 other lights in the house, you really don't have that option. But since you already have electricity going to the lights, if you can add like these low power, low cost thread network radios into them, you get a lot more control ability that you wouldn't have through just point-to-point wiring.
Absolutely. So you were mentioning how you've got you can interface with REST APIs and stuff, and something that really strikes me about your documentation is that, like, as you mentioned, there's just so many options. So like, you know, you're using Zephyr, but whether people want to come at it from like a REST API or like doing command line stuff or doing graphical stuff, or you know, if they want to use CoAP or MQTT, all these, there's just so many different options that people really get to sort of work with whatever their current competency is, and they don't have to learn a whole new set of things in order to interface with your system. I'm curious. I'm not super familiar with CoAP and MQTT. I've heard a lot about MQTT, but not so much about CoAP. Could you tell me what like the differences and what the advantages are of each one?
Sure. So CoAP is using UDP versus TCP, which is what MQTT usually uses. It doesn't have to use. I learned recently it doesn't have to use TCP. But generally, we find so we started with cellular, and we found that the overhead was lower for CoAP. And so basically, when you're sending cellular stuff back, you're sending stuff back through cellular network. You are charged for the data. And so you want to kind of constrain that stuff down. We also layered like serialization and compression on top of it using something called CBOR. And so basically, we're just trying to make packets really, really small. John, our founder, the Golioth founder, he is really the one to ask the CoAP question to, but we do support both. And all of our stuff is kind of CoAP first, I would say. Now, that actually benefits us for things like Thread, which is also talking CoAP over UDP, if I'm saying all this stuff right. I think the real thing to think about, though, is that it's completely seamless to the user, right? So me as a hardware engineer doing a little more firmware, getting better at firmware, hopefully, I don't have to think about the CoAP stuff. You know, if we dig into like Wireshark, like so Mike and I did a video about Wireshark specifically for Thread, then you might see the CoAP stuff there. But the real thing to think about is that we want it to be like, if you're using the Golioth SDK in Zephyr or in ESP IDF, it's like LakeDB state.write. That's like our state database, and that's all you're really going to interface with. And then you're going to see the console, and you're going to see the stuff on your device. And actually, we should maybe show the console at some point here too, because that's really, we're showing a lot of dashboards here. It's kind of hard to show the pieces that Golioth's doing because it is really, the Golioth stuff is the servers. And then, but all of the stuff that Mike and I do to try and showcase this out in the world, we're building hardware, and that's the fun stuff. But like the Golioth stuff is the servers, which, can run on our servers or can run on our customer servers. And then the device side code is all open source to be able to help people talk back to those servers in a really easy way.
Yes.
We never think about it.
We have a comment from Morgan as well. Started experimenting with CoAP over LoRa, showing a lot of potential.
Oh, cool.
Glad to see everybody's interest in it. Oh yeah, for low power, long range applications, outdoor stuff. Wonderful.
Yeah, LoRa's an amazing like physical layer, and we know currently LoRaWAN is one that people think about often, right? So it's actually like a network around on top of LoRa. We don't actually do LoRaWAN right now because everything that we talk to needs to have an IP address. That's why Thread works. Each little, so like this little Bluetoothy style device has an IP address, IPv6 address, which is crazy, right? It's individually addressable.
Yeah.
So we need that right now. Something like LoRaWAN usually has like a concentrator hub where you might have a bunch of devices talking back to a hub. So until we have IP addresses, and I might even be wrong about LoRaWAN specifically, but we don't support LoRaWAN right now or LoRa unless you do something completely custom.
So, but maybe in the future. Morgan thinks it's overburdened anyway. Cool. So you've got all these options on here. I just wanted to expand some of the stuff along the side here because your documentation is so in-depth about all these different options. But also, I think I read that you're also able to add your own boards. You don't have to use... we've got some questions in here about the ESP32, and you don't have to use the NRF 9160, even though there's like, okay, I was scrolling through this a little bit earlier, and there's just a massive massive number of boards, most of which are in the unverified section. So I'm not. Does that just mean that like you believe it works, but you haven't actually tried it?
So the way that this works is that anything that runs Zephyr and has a connection to the internet should work with Golioth. We make sure that we have like top level support that are like continuously verified. We actually have hardware in the loop runners, so that every time a commit is pushed to our open source SDK, it tests it out on those boards like the NRF 9160 and the MIM XRT 1060. All of these boards to make sure that with each iteration of the SDK, stuff's working exactly how it should work. With the rest of the boards, if they run Zephyr and they have a connection, they should work with Golioth. We're just not running that same type of all the time testing. And so for things like making your own board, so the mag tag is not supported in Zephyr like officially, but Espressif maintains a support for the ESP32S2. And so what we're doing is just taking all of the definitions for that board and then adding the pinouts that we're using for it. So we tell it like, here's the pins for the e-paper display, and here's the pins for the NeoPixels. And from there, the way that the Zephyr RTOS works is it just looks for basically the definition of those pins. So I have a pin called like Neo Power that turns on the power rail, and another one called NeoPixel that just runs the NeoPixels. And once you do that, it'll work just fine. And so if you then go and spin your own board that has a different chip but has all the same peripherals, in Zephyr, you can just, again, identify which pins go to those different peripherals, and the code should just run. It's really pretty miraculous. It's a little bit of a trick wrapping your head around how it's called device tree, the way that you kind of abstract that hardware. They borrow it from Linux. The Zephyr project is maintained by the Linux Foundation. And so a lot of the really great things from building Linux are being brought like into the microcontroller world. And it's really kind of exciting to see it take form. Possibly the best part of it is there's a ton of buy-in from the manufacturers themselves. So like Espressif's maintaining their implementation, and Infineon's maintaining their implementation, Nordic's maintaining theirs. And actually Nordic has gone all in and said that like all new products that they bring out are going to use Zephyr as their software layer. So if you haven't heard of it before, it's pretty exciting. From a firmware perspective, like I don't want to deal with network stack basically ever. And network stack's built in to Zephyr and very well integrated. And so for the most part, things work and you don't have to get under the hood with, do I have a socket and what is the socket doing?
Yeah. We have some love for CoAP plus cellular under here, but yeah. Also, Michael says
that's Simon from DataCake. Hey, Simon.
Hey, excellent. And I've been noticing that y'all have some new pages popping up under here in my control screen. So, would you like to show us your other demo? And I also would love to ask you a bit more about yourselves personally, because you've been in this community for ages, and you've really built up a following, each of you, in your own ways, and it just seems like we should dig into that a little bit. But first, I know that you have another demo, and I'd love to hear about that.
Sure. Yeah, let me switch my camera, actually. You can show my screen real quick as well, as I'm switching cameras.
So can you hear it? There we go.
Yep.
The red demo.
So this should actually be the desk. And so this is our little glamour shot of the devices down here in the lower right.
Yeah.
So these are little pucks that come from Layered, which is a device maker. Internally, it's got a NRF52840, which is in a lot of Bluetooth commercial products. These are normally gray. I spray painted them red, so that's why they look a little janky. But there's also a button. These are IP67 sealed, and it's got a sensor. It's got a temperature sensor. It's got an accelerometer. It's got a magnetic sensor. And so what we did is we basically have this. So these are all wireless. This one's plugged in just for debugging. But these are wireless battery-based devices. These are all meshed together. And they're currently talking to this Raspberry Pi screen here. I'm not sure how it's showing up on there. But basically, these are all connected back through what's called a border router. So this Raspberry Pi is set up as a border router. And basically what this does is it says, hey, you have an IPv6 address. I'm going wire radio layer. I'm not sure what that 15.4 is. And I'm going to be able to talk to you on a physical layer and get stuff back to this area. And then I'm going to forward it along. So to this device, right? This is a little tiny Bluetooth battery powered device. This basically doesn't know that this border router is here. It's basically just forwarding packets along to the rest of the internet. And so this knows to go talk. It's saying, hey, I want to go talk to the Golioth servers. It's got CoAP.Golioth.io or whatever address is for that. When I press a button here, it's actually going through the border router out to the broader internet, talking to the Golioth servers and registering a data packet. And so if you switch back to my screen real quick, you should be able to see.
There we go.
Yep. And so as I'm pressing the button, you should be able to see. This one might not be playing nice.
Come on, little puck.
There it goes.
Hey, there we go.
There it goes. Yeah. So basically, as I'm just rotating this around, it's just taking accelerometer readings. You can see these things have been capturing data every 60 seconds on the historical temperature side of things. And so, but basically, all of this data is just coming back to the Golioth network every time I press the button. Now, if we want to see what that actually looks like on the console, so again, this is just showing up like any other device. If we go to console.golioth.io, this is what it looks like when you're logged in. Anyone can get a free developer account. 50 devices are free forever. So you could build up a pretty decent sized little network if you want to. I'm on Wi-Fi, so apparently
that's a lot of robots. I secretly want to have like a little robot swarm. I've seen Sarah Petkus's like bot swarm of the little dancing guys, and I totally would love to have my companion bots talk to each other.
Okay, console's not playing nice right now. But basically, there is a management layer there, so you could see the data coming in.
Chris, I have mine up if you want to guide me through it in the console.
Sure, that's great.
Yeah,
thanks.
What should I go to?
Red demo. You're at red demo up?
I'm at red demo, yep.
So just go into one of the, how about device number 2?
Device sensor 2. All right.
And so here, this is actually showing, this is for the specific device that I have my hand here. And if we go to LightDB stream, that's basically our time series database here. And you could see that basically I'm sending back the data that's happening, every time I press a button. You should see a new piece of data come in here. Oh, yeah, there we go.
Nice.
Press it. There it goes.
There we
There's
go.
some new data. All right. And there's another new data.
Yeah, and so it's just taking, just pretty standard, sending data back over this sort of thing. But it's not just this, right? So this is kind of like the table stakes for any IoT system, is just sending back sensor data.
Totally.
There's other things like
it's still magical though.
It is still magical, of course, and especially because this is going over a thread network, right? These are all meshed together. It's talking back to a border router. This little tiny thing is actually talking to the broader internet. Like that's crazy. And thread feels like magic to me every time I use it. If you go back to Mike's screen real quick, you can see we also do things like logs, and so we're actually sending back logging data. This is all set to debug, but this is all selectable, so you don't have to send back all this data. You can, so say you're just trying to troubleshoot what's going on here. You might have some error logs. You might have, so the 4 things are debug, info, warn, and error. And so basically you could start to filter based on that and see what's actually being sent back from each individual device. You could filter by, we're on an individual device page right now.
Right.
Other things that are really cool, but not set up on this project, we can show it on the next project if you want, is settings. I guess we should wait for that sort of thing. And then, I guess that is not implemented.
It's out of sync because the device doesn't know about it.
Yeah. So we could show that other stuff in a different demo. I have another cellular demo if we're interested in seeing that.
Sure. Love
we
all
can do
demos.
firmware updates as well. All the demos. Okay.
Yes.
Let's get this stuff out of here. So this is something we just posted about recently. This is a trash can demo. And so, pretty boring black box.
Very small
but you can see
trash
here,
Sorry.
there is there's a hole here for a time of flight sensor. And there's also another hole for just gathering weather information. If you look inside, this is very simple, just, dev boards, nothing, dev boards and a lot of hot glue, really. And so this is just like I said, just a reference design to talk back to the network here.
I've seen plenty of like deployed commercial devices that were much more terrible than this. So
Exactly.
don't sell yourself short.
Yeah, and so if we go, mine is playing. It's my dashboard is up on my screen now, so we should be able to see the same kind of thing here on my screen now. And so, what we see right now is that this thing is updating based on distance. So you can see it's tracking distance. It's tracking what we, just the trash level, because I've actually mapped different distances to how high the trash. Oh, you can't see my hands right now, but how close the trash is to the top of the trash can. And so we see right now it's since it is tipped over because I've got it upside down. It's
It's really cute
the desk. Yeah. Yes. Poor little trash can turtle.
Chris, maybe I blanked out. Did you mention that this gets installed and the trash can lid pointed down at the?
I didn't say that. No, so that's a good.
It makes sense with the time of flight sensor, though. Like measuring the fullness.
Yeah. So I could flip this up now. So now it's going to be pointed at the ceiling. The distance will go really much higher, I think. And basically, you'll see a change here on the console. We're also collecting things like just generic weather data. Gas, VOC. So basically, if someone dumps some paint into the trash can, that sort of thing. So you see now that it's at a meter. It's saying there's a meter up here above, and so now it's sensing that it's at a 0% fullness level. But what I was saying on the settings sensor here is that it's all adjustable, right? So actually, everything we do, we're able to push these calibrations effectively down to the device itself. And so I could go and change what the different sensing of 100% is or 0% all the way down to the device. We could also do things like go and change how often this thing's updating. So right now it's updating every 10 seconds. The default is like 600 seconds. So it's only because how often do you actually need to do that sort of thing. And so let's see, a Z threshold is basically when it's decided to tip over. And so basically all of these things are settable on the Golioth console to kind of like piece it all back together. So this is a feature that's on the Golioth console. This is a settings feature, and it gets pushed out from the Golioth servers down to each individual device it's directed at. And then you have the device SDK, so something in Zephyr that's basically listening for this change on. So if I go and change this to be 20 seconds, there's code. Actually, I could probably just show what it is. This is actually my terminal here. Because this is actually still plugged in right now. If I go and change this code to be every 20 seconds instead.
Can you zoom in a bit, Chris?
Might need a little bit larger text size. I'm like,
you see that it just got a bunch of CoAP data to go and say, hey, actually all your settings have changed and here's what they are. And so now it's gone and reset all of these settings that I just pushed down to the device. We should also see that it was synced a few seconds ago. So basically Golioth in this case is managing like the data side of things without having to be like a cloud guru. Mike and I are not cloud gurus. We were able to change a variable on a individual device. It gets pushed all the way through the system over the cellular network, all the way down to this device. And then it says, hey, I just got a new setting. I should do something different with this. And so it's then going and taking new action based on this. So interval of 20 seconds, right? Instead of 10 seconds. And so each of these things is programmable on an individual device basis, on something we call a Bluetooth base or blueprint basis. And then finally on the overall project basis as well. So these are the defaults for every new device I might add to the project.
Nice.
It just opens my mind too to think about this trash problem, because if you think about from a municipality level, you might have thousands of trash bins around the city. And then do you just send a truck to each one of those every week, even though it might only be 25% full and not have any like rotting trash in it? Not to mention the time of the people that are driving the truck. So you could do a much smarter algorithm to figure out which cans actually need to be empty. Let's just go to those in the most efficient way possible. Or like the thing that Chris just demonstrated, like I live in Madison, Wisconsin, and it's University of Wisconsin used to have a really good football team. And so they have like 75,000 people at each game. And if you think about those Saturdays, you probably need a lot more trash pickup. So you could remotely tell the trash cans all within, a mile of the stadium, hey, report back every, 4 minutes instead of every hour or twice a day or whatever. And you could end up not having a situation where trash is overflowing and people are just littering, or if, stuff gets tipped over, you could know that, maybe there's something wrong in that part of the neighborhood. Let's go and clean it up.
Yeah, I was a little tidbit. I was recently at Hardly Strictly Bluegrass in SF over the weekend, and another music thing recently. It's a great thing, but also you do end up with, they put out trash cans, but also you still see this like sort of almost like a cinder cone, like a mound of trash, like growing up around.
Right.
So it's kind of like almost becoming this slope up to the mouth of the trash can, and it's like, I wish that this type of thing, exactly being able to tell if at an event the can is full. Another thing that you mentioned a minute ago about in your demo, you're sort of setting the update time to be 20 seconds instead of 10, and that's another, of course, like another low power feature. I love that you mentioned that CoAP has the benefit of being UDP versus TCP, so instead of maintaining that persistent connection and having to spend all that energy on maintaining that tunnel, you can just send little packets every now and then. You can check them every 20 seconds, every hour, whatever. Super good.
Yeah.
Love it.
Yep. Yeah, I mean, any kind of battery-based cellular thing, you're really digging into more of the protocol stuff. And I think one of the benefits of, a lot of kind of platforms that are out there, they're basically like, well, don't think about anything here, right? And it's like, well, that works great in prototyping stage, but once you get past prototyping, you're like, no, now I need to make my battery last for a year or 2 years or 5 years. Unfortunately, that's kind of part of the engineering gig, is just like you're going to have to dig into some of that stuff. And so, the Zephyr stuff is tough to learn up front, or ESP-IDF is tough to learn up front, but being able to get under the hood when you need to, that part is really, really useful, I think.
So we're about 40 minutes, and I want to bring up Gustavo's comment here. Greetings to all, especially Chris Gammell. Thanks for your videos. I learned to use KiCad, or thanks to your videos, I learned to use KiCad. And this he's referencing the wonderful Getting to Blinky series. And I didn't realize this, but I didn't realize that he learned
out
from
of
you.
Date, unfortunately, right now.
You what?
I said they're wonderfully out of date. 5.0 was about 4 years old.
I was going to ask you about that. But funnily enough, Gustavo is the one who created our Auschwitz Octopus badge for Hackster, which is this adorable badge. And so you're basically responsible partly, obviously Gustavo is the creator, but like for the creation of this badge. It's so cool.
Right.
I love this thing. We've put together a ton of these kits in the office and stuff, so it's lovely to see you on the stream, Gustavo. But yeah, so Getting to Blinky, obviously KiCad is now on version 6. And but maybe you can tell us a little bit about what the Getting to Blinky series is. You've done several versions already, and it's kind of a huge undertaking. You've got this beautiful website where it includes, you just go through the course, and yeah, maybe the future of the project.
Sure. Yeah. So Contextual Electronics is like my online course for teaching people electronics. It covers KiCad all the way through to how to build, your projects, up through consulting, even stuff like that. And it started back in 2014, and the KiCad project, or KiCad project, was very rough back then. And so that's when I had started making videos, and then eventually I put them out on YouTube. But they started as like part of the course, and then I kind of put them out on YouTube later. And then around that time, I started the forum as well, the KiCad.forum or forum.kicad.info. And that's been just a great community, and the project just keeps getting better because of all the contributors to it. So, and actually the green demo, the blue demo, all of the faceplates and the Aludel base, those are all built using the same software as well.
I wanted to know. Yes, I was wondering if that was you. That tree is gorgeous on the green one. I'm trying not to yell into the mic, but it's very exciting for me to see those. They're gorgeous. And
Alex, you've built your guitar. Didn't you build a guitar based thing? Or I remember you doing some project. Was that KiCad based or no?
I do use KiCad for all my PCB projects. I made a little Ouija board planchette ESP8266 programmer /earring. You might be talking about I don't know if you're talking about the Fenderino, but I don't know who. Or no, I do. I think it was David Quartiers and his team. But
you weren't working on like a pedal or anything like that. I watched one of your projects at one point.
Very likely, I was very likely doing that. I also made. I've been making some for the for companion bots. So like the little companion core with the skeleton on it. This is actually very spooky season. Maybe I should pull those up because it's a.
Do they all say doot?
I don't. I do want to make a doot board, but we've got like.
I was just thinking. Rob from SparkFun has the doot skeleton special edition ESP32 one.
I got one of those. They sent me one. It made me so happy.
Yeah.
Everyone that came out of an unboxing I did for SparkFun, where I misread the boot button on their board as doot, and it became a whole thing, which makes me very happy. And now they put out a doot themed. Was it featherboard? I think. No, it was the thingy. Their ESP8266 thingy.
They have a Thing Plus ESP32. That was the special edition one.
Oh, you know what? I got on the thingy track because I saw on your desk you had what I thought was a Nordic Thingy 91.
That's right.
Yeah.
We have a orange demo as well. We call it, which is borrowing a bit from the Thingy 91. But the nice thing is, so like you get something like this, right? This is like a puck that a Nordic Semiconductor sells with a bunch of sensors and the NRF 9160 internal. It's got a battery. And so basically this thing is like a little asset tracker. We found that if you want to move outside of the Nordic examples, we wanted to build something that was outside of that, right? So not necessarily talking to AWS, but maybe talking to something like Golioth. And so Mike wrote this great application, basically grabbing GPS readings, sending it back to Golioth. We showcase it on a Grafana dashboard like we did here. John, our founder, when we were in Germany, he actually drove to Italy from Germany. So it was like all going through Liechtenstein. What's between the countries? I don't know what the country is. But yeah, so basically asset tracking and similar kind of things, just kind of showing that you can take an off-the-shelf device like this and reprogram it in Zephyr, use it, send the data to something like Golioth, and be able to use that in a basically a commercial context. Not saying you would use this as a end product, but like basically showcasing that you can have that flexibility when you're using a Zephyr-based thing in the beginning.
Cool. And where would we be able to find that demo that Mike put together? Online somewhere, perhaps?
Probably the video is the best place to start for that sort of thing.
Okay. Are you on YouTube?
I will send you a link for that here.
Cool. Great. And just, I don't want to get too far off track because I asked you a question and then we kind of got into the weeds, but I do want to make sure that you get a chance to talk about what your plans are with future versions of this EDA software, which I actually prefer the sound of KiCad, just like aesthetically, but it turns out I've been told.
You're told I'm wrong many times over. Yeah.
Because they're French, right?
That's right.
Oh, and I missed a link from Mike as well, showing us some cool stuff.
Oh, yeah, I think it's going to the same place.
Cool. Yeah. Golioth Orange demo. Sweet. I'll put this in the link, this link in the description of the video. Everybody, as per usual, we have most of the links that we see here in the description. If they're not there now, that's because I can't time travel, and I'll put them in after the video. Very exciting though. Orange demo. Also, this is very seasonal too. Orange and black. Love it.
Oh yeah.
Oh yeah. Already, I got. Lauren says I just got my hands on the Thingy 91. We'll try out this demo. Yes. Love it.
Yeah.
So yeah, KiCad is on.
I mean, version 6 has been amazing. I mean, they keep adding more and more stuff to it. And the development team keeps growing. They're all over the world. That's just been, the project's just really on a great trajectory. So, I don't know what else to say about it other than there was no KaiCon this year, and so hopefully next year. I think by next year we'll have another conference. I ran the 2019 conference in Chicago, and so hopefully we'll be able to do another one.
I would love to go to one of those. I started playing around with PCBs. I think actually during like the New Year's period between 2020 and 2021, and just to really, I love David is, you know, I'm sure you can kind of do whatever you want, but if you say KiCad, people are gonna correct you. So, you know, and now apparently I'm one of those people. It is an amazing piece of software, though. Yeah.
I attended that conference back in 2019, and I thought it was a ton of fun just to see the different ways that people were customizing the use of KiCad for their application. So, like there were people talking about like automating layout. So if you're laying out like some insane, 2,000 parts in a very specific way, like scripting through that. And then there was a great talk on, actually, there may have been several talks on 3D rendering for the previews of boards and the previews of assemblies.
Oh, yeah.
And then there was like an open panel discussion between the KiCad maintainers about like what the challenges of the project are and where the challenge is going. And I think at face value, you might say, oh, I don't know what there would be at this, design software conference, but it's really seeing the different people and how they're using it was really informative to me and opened my eyes up on the other things that I hadn't thought about that you could use the tool for.
Ooh, cool. And Chris, just I meant to ask you, what are you excited about in the new version? Like what tools you're especially stoked for, or upgrades to things that were already in there?
I mean, I find that the workflow kind of stuff is really useful. So making it easier to export boards, making it easier to use plugins. So like the plugin manager is just so much easier than it used to be as well. So that really extends a lot of the stuff that's out there. So I saw Greg Davil was on the Hackster Café.
Yep.
Greg put together like a Python based like a bubble. It was like bubble text for creating nicer looking labels for your boards. And he was able to roll that into the Python-based marketplace really easy. And so the community is really, really powerful. I feel like not just the forum, but the people that are developing these things, extending things. There's a KiKit or KeyKit is another it's like a not just a panelization tool, but like it's a suite of tools, and it just keeps growing. I forget the name of the developer for that, but basically just making it really easy for people to contribute to it without being like the main core software is written with C++, but all of the Python scriptable stuff, a lot of people write Python, myself excluded. Mike's a Python person, and basically being able to then even just go and write something. I think Mike talked about this a little bit as well, but just like being able to make a circle of LEDs and like script that sort of thing, super easy. And make it really extensible. So that's what I'm always really excited about, because it just brings more people in, makes it more accessible, brings more software people in, which ultimately benefits the project a whole lot as well, because there's just kind of different extensions and scalability things that software people usually are good at.
Yeah. Personally, I'm more of I understand hardware a little bit better than I understand software, just intuitively. But I love the idea of being able to script like a circle of LEDs like you're talking about, because I totally do. I get very particular about aesthetic stuff in my PCBs, because I'm doing like very graphical things, and I would love to. So maybe I can use it in sort of the opposite way, where I'm using it to learn a bit more about programming, because I want to use it to script stuff for my PCBs. So I got this link from you, Chris, and could you tell us what this is?
This is the playlist of all the KiCon videos. So
this is the whole playlist. Great.
Yeah,
we'll put that
all
link
the
in the
stuff Mike was
description.
talking about. Yep.
Surely there must be. Do people argue about KiCon versus KeyCon as well, or is it KiCon?
Well, I ran the event, so it was KiCon.
All right, cool. I think it just has a better ring to it, and
it's good to be king.
So, all right, we've got about 10 minutes left, and Mike, we haven't tortured you yet.
Oh no, torture away.
I'm very excited to hear about what you're doing with music, because it's in your Twitter bio, which means it's fair game. And do you what kind of music do you do? B, does it overlap with your electronic stuff in any way? Because I'm always looking for ways to like combine the two. It's you have multiple passions, and
it's surprising how many people you run into in tech that are like also super into music, right? And I don't know if it's like that way everywhere, but my feeling is it's not. For me, I came from the other side of it, though. I'm a professional musician. I play in the two orchestras here in town, the Madison Symphony and the Wisconsin Chamber Orchestra. I play French horn, and all of my schooling is in music. So I have an undergraduate and a master's degree in music performance. And moved here to play at the orchestras about 20 years ago, 19 years ago or something. But all along that way, like I'd always been doing tech stuff. So like my first job in high school was working for an internet service provider, doing tech support. And I was building Beam Robotics and like really getting into that stuff. And I think that when I got to the point where I was like, oh, you can put microcontrollers into these robots you're building and do a lot more interesting stuff. Because, I was like doing line follower robots using comparators that could see like the white paper versus like the black line that it was following. But, they're just not very smart. Like once it goes around in a circle a whole bunch of times, you're like, I want to do something else. And I got that first basic stamp. And I was like, oh my God, this is so cool. And then I was trying to do like multiplexing on a display, and those are super slow. And this is still kind of like the pre-Arduino era. And so I got into AVR microcontrollers. And those were like super fast, running 8 megahertz. And I guess from there, it's just been like a rabbit hole of like, yeah, I know, right? It's just been like a rabbit hole of like, seeing these peripherals come out and these chips get bigger and bigger and faster, like that chip that's running on the Teensy 4, the one that's on this Ethernet board that we support. Like but it's running 600 megahertz. It's got like every peripheral under the sun. It's just amazing. And so I think I have a really great curiosity for like, what can you build into these tiny pieces of silicon, and what can you do with it with the code that you flash to it?
Oh man, there's some new stuff.
Second, that Mike is a very curious person and way better at firmware than I'll ever be. So.
There's some
don't
really
don't let him say the music schooling is holding him back in any way.
I went to school for human languages, so
really?
I can't get at you for that.
Well, I think it's like school is really how to learn, right? And I think the best schooling you can get is if you are learning how to teach yourself things like, oh, okay, here's my job and I'm in this lane, but there's something over here that I need to do my job better. Like having that skill to be like, what do I need to do to get over there is, I think, the greatest thing you could take out of college.
Yeah, and we get really dangerous when you combine that with people who have like curiosity about stuff, and you're learning stuff just for your passion, and then it turns out to inform the stuff that you're doing for your work, and like it's just a great combo. Chris, what about you? Are there other hobbies or passions that you have that sort of like either complement in like making you a well-rounded person, or interact with your electronics in some way? Obviously, you do beautiful visual art. That tree is gorgeous.
Thank you. I am not super well-rounded. I do electronics hardware meetups on the weekends, and I have a podcast about electronics called The Amp Hour that's been going for 12 years.
Oh yeah.
So pretty solidly in the electronics space. I do play a little bit of piano. There's a piano down here, but I'm not very good at it. But
you look at these though. Did you?
Yeah.
Where's this tree from? How did this?
I don't remember. I traced it out of somewhere. So
cool. Yeah. Well, and then just like the way that these are put together is so nice. Watching the little LEDs sort of like flow from one side to the other, and the cool thing they do in the middle.
Yeah.
But you put the board together. It's anyway, collaboration.
Yes, teamwork. Teamwork makes the dream work.
I'm going to make it wholesome whether you like it or not. Cool.
It is. Don't tell anybody at our work, but really, Chris and I just want to hang around with each other all day long, sending memes to each other. And this job happens to allow that. And so we were like, all right, let's do it.
And as Ben mentions, Chris is super well-rounded community
man. My former boss, Ben, is nice enough to drop in and say nice but, we got them lined up. We got people lined up for, dropping in nice comments. So. Thanks, Ben.
It's true though. Like running a community is terrifying for me because like it takes so much thoughtfulness and attention, and it's easy to get entranced by physical objects and like pretty projects and things you're excited about. But creating stuff that people connect with in the way of your podcast or your YouTube channel, and the way that Gustavo was like, I learned how to use KiCad and make these. Now I'm doing it. KiCad. Yeah, amazing. Y'all are so cool, and it's such a pleasure to have you on the show. Is there anything you'd like to throw in there before we wrap up here? Last thoughts about upcoming stuff?
Well, I would like to say that, so as part of this job, I've had to really quick learn Zephyr, real-time operating system. And it's great, but there's not a ton of learning stuff out there. So if you check out, every time Chris or I learn something new in Zephyr, we try to write a blog post about it. So blogs.goliath with an O in it.io is I think a great place
blog,
to
Mike, singular.
blog.goliath. Yeah. Yeah. So I just did this one yesterday on threads, work queues, and message queues, and how we're using those differently. Things like, if you're trying to record GPS and you don't currently have a connection to the internet, what do you do with that data until you do have a connection to the internet? And stuff where it's it's all built into the system, and sometimes you just need help finding the path of exploration on what you should learn next and try out.
I love it. Yeah. And it's one of the benefits of having people in a DevRel position who, or a similar position, who are learning themselves. Often, we hear it all the time, people who are super advanced engineers and have been doing that their whole lives, and you don't really know what people need to learn in order to get up to speed on it. And you're really providing that for people through your own journey. Love it.
Yeah.
And if you do want to learn more about this, yeah.
See, nice lead in, Mike. We do training. We're going to be doing training at SuperCon. They haven't started selling the tickets for the training yet, but we also do training for companies. Mike mentioned the blogs. What else can we say there? People can sign up for free. It's real easy to get started. There's docs.goliath.io. There's a getting started page. If you already have an ESP32, that's probably where most people kind of have one floating around their desk. Or if not, they're $10. And, getting started there, sending data back to the network. You could, especially if you're using ESP32, you can use our Zephyr SDK or our ESP IDF SDK. And so you could just kind of start building stuff out and sending data. The first time I got stuff sending back and forth between the internet and a device, it was really, really tough. And it's getting easier and easier. And I think we help make that easiasier. So people should try that out.
Okay, everyone, go check out the docs. Get started for free really quickly. You can use your ESP32, as Chris Gammell mentioned, or any of the other boards that you have lying around that are in that massive list that I was scrolling through earlier. Mike, also, thank you so much for joining us. And everyone, come to SuperCon. We'll see you there, and I'm excited to check out the workshop. If I manage to get a spot in there, we'll see. I bet it fills up fast. But yeah. Come join us, check out the trainings, check out all the other cool stuff that they're doing over at Golioth with an O, as someone mentioned in the comments here. And yeah, thank you so much again for joining us. Thank you to all of our audience members. You've been great. Have an awesome rest of your day and hack on.
Thanks,
Zach. This was fun.
Cheers.
Yeah, I love being here.